Hello. In this part of the video that I'm working on, I would be calculating the perpendicular distance between SR and PQ. Just to mention, this is the second part of the video in which you try to find the area within a question based on bearing. Here we've been asked to find the distance between SR and PQ. Now, what does this word perpendicular distance mean? The word perpendicular distance simply means that to this parallel that I have already mentioned in the last video, SR and PQ being parallel, this distance that I'm marking must be the shortest distance. Shortest distance, that's what it really means when you say the perpendicular distance. You must put this understanding, and there will be a lot of questions based on bearings which uses this term particularly. So we're interested in finding this distance, and how can we go about this? Now if you look at the information, we have a triangle. Let me call this point as, say, some x. So in the triangle PSX, we have an information, and that this side SP, which happens to be the hypotenuse of this right angle triangle, because I drew the perpendicular, the shortest distance, therefore I can use sine, a trigonometric ratio as sine, in order to work on that. Now you may ask me, why should I use sine and why can't I simply use a Pythagoras theorem? Well, the Pythagoras theorem primarily requires at least two sides known out of a right angle triangle in order to find the third one. So instead, here we have an angle given to us. So I can use sine over here as sine of 70 degrees, which is equal to its opposite, which becomes the perpendicular distance which is in question over here, which is, let me call this as, say, an h. That's h over a 300, which is the hypotenuse. It may help you recollect that sine of an angle is always equal to the opposite upon the hypotenuse. So the distance h becomes 300 times sine of 70 degrees. Sorry. If you can take your calculator and check the value, that should give us a 281.9. The h is a 281.9 approximately meters, which is surely less than the hypotenuse. So, but then we would like to leave our answers to three significant figures. This is 4. If you like to leave it at three significant figures, we can approximate it to 282 meters. Okay? Well, in my next video, I'll be calculating the area of this entire field, PQRS, in square meters.